Hello, first of all, let me introduce myself. My name is Infantri Siahaan, and I am mechanical engineering student at Udayana University. Now I want to presenting topic about fabrication and finishing of metal products. So this is the topic that I will presenting. There are the formation process, primary production mills, forging, drawing and extraction, forming, powder metallurgy, material removal process, and joining process. Introduction. Metal products that are subject to mechanical reduction operation subsequent to casting and solidification are referred to as work products. These products can be shaped, finished, and assembled by using a variety of metalworking techniques, which may include methods for forming, material removal, and joining. Depending on the alloy system and the intended application for the finished product, there are a staggering number of production techniques that may be employed. The first topic is the formation process. Metal forming equipment. Metal forming is done with a large variety of machines or equipment such as rolling mills for plate, strip, and shapes, machines for profile rolling from strip, ring rolling machines, thread rolling and surface rolling machines, magnetic and explosive forming machines, draw bench for tube and rod, wire and rod drawing machines, and machines for pressing type operation or presses. The significant characteristics that comprise all design and performance data pertinent to the economical use of these machines include 1. Characteristic for load and energy, available energy, and efficiency factor, which equal the energy available for workpiece deformation or energy supply to the machine. Second is time-related characteristic, number of stroke per minute, contact time under pressure, and velocity under pressure. Third is characteristic for accuracy, for example, the flexion of the ram and frame, particularly under off-center loading and press stiffness. Next is primary production mills. The next step is the mill processing of blooms, billets, and slabs to produce various product forms such as plate, sheet, strip, and bar. The metal of these work products is stronger and much more homogeneous, that is, uniform in grain structure, than at the ingot stage. These mill products may be provided in finished form for application, or the product may undergo additional processing, such as forging, stamping, machining, welding, and other, for an end product ranging from soda cans to panel, destined for car and pickup truck bodies. So, in this picture, we can see how production about from blooms, billets, and slab to a product like this. We can see sheet and coil. How from billets be wire, nails, wire fabric. How blooms be beams like this, and another. You can see there. So this is the primary production mills. Next, drawing and extraction. Drawing and extraction are based respectively on the pulling and fusing of section through dies. In the drawing process, the cross-sectional area and or shape of a rod, bar, tube, or wire is reduced by pulling it through a die. The deformation is accomplished by a combination of tensile and compressive stress that are created by the pulling force at the exit from the die and by the die configuration, like this drawing process. Metal flow during extrusion through a conical die is analogous to drawing because the metal is forced through the die region. The main difference is that extrusion involves either fusing the workpiece through the die, direct extrusion, or fusing a die over a stationary workpiece, or indirect extrusion. Extrusion dies and profiles can be more complex than the reduced profile generated by drawing. Drawing also is usually done cold, while most metals are hot extruded. Forming. Metal bar, tube, plate, and sheet are formed by various bending, stretching, and drawing operations. Bar and tube are formed mainly by bending operations such as compression bending, stretch bending, draw bending, and roll bending. Sheet forming includes various bending, stretching, and drawing operations, plus some special method to develop surface with deep recesses like spinning, deep drawing, or shallow recesses like dimpling, juggling, and explosive forming. Okay, this is how we forming metal bar, how we forming bar and tube and sheet forming. You can see how bar and tube with compressing bending, draw bending, stretch bending, roll bending, and sheet forming here using shearing, blending of blanks, stretch forming, deep drawing, spinning of metal sheet, and explosive forming. This is the example about compression bending, draw bending, and bending roll or roll bending. Next is powder metallurgy. Powder metallurgy, or PM, is a growing branch of metallurgy based on the production of material in the form of metal powder and the manufacturing of parts from this material. Powders of metal and alloys also are fabricated into parts for several reasons. Most importantly, parts of complex shapes, close tolerance, control density, and control properties can be produced by PM method. The most common method of PM part production is the two-step process of powder compaction by pressing and densification by sintering, referred to as PM pressing and sintering. Next, material removal process. Material removal process, of which machining is a special class, or secondary manufacturing operation used to achieve precise tolerance and control surface finishes. Machining is used to convert casting, forgings, or preform blocks of metal into desired shapes with size and finish specified to fulfill design requirement. So this is the process how we can the process of material removal process, such conventional machining operation like turning, drilling, milling, boring, planing, shaping, reaming, and tapping, where material is removed from the workpiece in the form of a chip. Next is abrasive process, such as grinding and honing, where small particles are removed from the workpiece by abrasion with a hard tool. Abrasive process have lower material removal rates and higher energy requirement than conventional machining process, but can produce closer tolerance and finer surface finishes. Next is non-traditional machining process, which include electrical discharge machining or EDM, electrochemical machining ECM, and ultrasonic machining or USM. Joining process. Joining process, there are welding, like example arc welding, resistance welding, solid state welding, and brazing and soldering. Okay, this is arc welding. Number one is SMAW, the SMAW, or shielded metal arc welding. Commonly called stick or cover electrode welding is a manual welding process whereby an arc is generated between a flux cover consumable electrode and the workpiece. The filler metal is deposited from the electrode and use the composition of the flux covering to generate a shielding gas and to provide fluxing elements that protect the molten metal. Next is GMAW or gas metal arc welding. In GMAW, the electrode, weld pull, arc, and adjacent area of the base metal workpiece are protected from atmospheric contamination by a gaseous shield provided by a stream of gas or mixture of gases feed through the welding gun. The gas shield must provide full protection because even a small amount of entrained air can contaminate the weld deposit. Originally, only inert gas such as argon and helium were used for shielding, but today, carbon dioxide is also used and may be mixed with the inert gases. GTAW, or gas tungsten arc welding. This is also known as tungsten inert gas or TIG welding. Heat is produced between a non-consumable electrode and the workpiece metal. Because the electrode is non-consumable, a weld can be made by fusion without the addition of a filler metal, although filler metal is often used in this process. The electrode, weld pool, arc, and heat affected zone are protected from atmospheric contamination by a gaseous shield provided by a stream of gas that is usually inert or by a mixture of gases. So, GTAW is usually using in a thin workpiece. You can see this is the picture of example of GTAW, a thin workpiece. Okay, next is resistance welding. Resistance welding is the joining of two metals using pressure and electrical current for a set length of time through the area of the metal to be joined. The key advantage of resistance welding is no other materials such as shielding gases, fluxes, or filler rod are required in the union of the metals. So, resistance welding, for example, is in the left is resistance spot welding, and resistance seam welding. Spot welding join with point form. Seam welding, so this process is joined from through the layer, all the layer. Different with spot welding is only a point by point. That's the difference of spot welding and seam welding. Next is friction welding. Friction welding is a solid state bonding process that produces high integrity full contact joints. By rotating one workpiece relative to another, whilst under a compressive axial force, the friction generated between the two faying surfaces produces heat, causing the interface material to plasticize. Brazing and soldering. Brazing involves joining solid metals in close proximity by introducing a liquid metal that melts above 450 degrees Celsius. A sound braze joint generally results when an appropriate filler alloy is selected. The parent metal surfaces are cleaned and remain clean during heating to the flow temperature of the brazing alloy, and a suitable joint design that allows capillary action is used. The last is soldering. Soldering is a process used for joining metal parts to form a mechanical or electrical bond. Different with brazing, it typically uses a low melting point metal alloy, solder, which is melted and applied to the metal parts to be joined, and this bonds to the metal parts and form a connection when the solder solidifies. Okay, that I can presenting about this topic. So thank you for your attention, and I say thank you.